Hello guys. I actually came to do this video after one of the guys commented on one of my videos saying, can you do a up-down counter using a Delta PLC? Okay, so this is where it starts. You've got a range of PLCs within the Delta PLC. Depending on the PLC that you have at hand, you need to refer to the manual. So this manual is supporting these models, ES2, all these ones written here. So they are telling you from C0 to C199 is only count up, nothing else. And it's a 16-bit. And then from C200 to C231, you can achieve up-down count, and it's a 32-bit counters. Okay, which means you can count within this range from, it's like, I don't know, 2 million or something, 2 billion, I don't know what that value is. From negative this to positive that. So this is just a general counter, as these ones is same as C0 to 199. They are just general counters, nothing special. But from this range, it's a high-speed counter where you can put in your encoders, where you can put your high-speed pulses, is this range. Okay, so it's always good to refer to the manual. So take note, the up-down, it only comes as a 32-bit. And then we come here to this graph here. And then they'll tell you that there is a, for you to achieve the countdown within a Delta PLC, there's a certain bit that you must switch on, and this bit corresponds to your counter that you have selected. Oh, it's not here. It's actually okay. So I'm not so sure where I saw that one. Like for the counter C200, you need to switch on. Where was that bit now? Yeah, this is what I was looking for. This is what I was looking for. Something like this. So you see, it's telling you that on C235, yeah, you need to switch on this bit M1235 for you to achieve like the up down. See, so this one's at the bottom here. So they've got like corresponding registers. That's how it works. So for our C200, the one that you are working on now, the C200, the bit that you are working with is a M1200. Okay. So I'm gonna move to the example of up-down counter. This is an up-down counter. So this M1200 is to determine the direction of up-down counter. So as a programmer, it's always wise. It's always wise all the time to refer to the manual. You cannot program a certain PLC without referring to the manual. It's actually guiding you throughout the hardware architecture and how the firmware and the PLC is interacting. Okay, so as you can see here, when you switch on that bit, the M1200 is actually this one on X10. When it's off, it counts up as a general counter. And then when it's on, it starts to count down, okay? And then when it reaches to the value that you have set, it switches on a bit, okay? And then when it goes just slightly below that value, it's gonna switch off. I'm gonna show you in the example. What I'm saying is, they're saying when the counter counts from 6 to 5, this is from -6 to 5, which means it's incrementing. Remember, when you're incrementing, we go like to from -10, -9, -8, and -7, -6, -5. That's the target. That is the target here. Then it energizes the output. And then when you are now decrementing, we go from -5 to -6, and then it switches off. So I'm going to jump into the example quickly so that we don't get confused. Load M0. This is just a bit to energize the special register. Right. It's telling you that C200 counting mode on, countdown. When it's on, you count down. Okay. So there's something that I'm going to show you now. CNT. And then I say load M10 13. So this is a flag that goes on, off, on, off, on, off every half a second. So I don't want to switch on off the flag manually, like a bit manually. This is just gonna be blinking, doing the counting for me. So this count, we put count C200 here, and then I put a D0. This is where I'm gonna put the reference, the set value that I want. Okay, so if I compile here, you see this thing is giving me an error. Why? Because I used a 16-bit counter, this CNT. This CNT is a 16-bit counter, of which a C200, which is an up-down counter, the manual is saying it's a double word. That range, remember here, we are in the 32-bit counter. So a normal CNT cannot support. It has to be a D, like this one. Okay, it has to be a D, and then I delete this, I come back again. So it means this is a double counter. It's a double counter, this one. If you click here and then you check it, it's actually going to tell you it's it's not showing here, but the D is a double word. So it's 16 plus 16 give you 32. I'm surprised why it didn't change. It didn't change here. Maybe I'm supposed to compare first. I don't know. But that's what actually happens. Sorry. Okay, so we're done here. So what we need to do is the bit, the load C200. That is the bit that's gonna go on or off when our counter reaches whatever it's trying to do. And then I'm gonna have another one called M2. This one is used to reset the counter. Okay, so here I've selected my communication driver, which is driver 2. And driver 2, I think driver 2 is already running. You see, it's already, you always start your driver, it's already started. So then if I download now, okay, it's gonna download now. Okay. And then we're gonna go online. Right. So you can see this thing is already counting, and we don't have a set point here. So I'm gonna put my set point as -5. Okay. Right. Minus 21. This counter is already on 21. 21. Remember, 21 or 25, 27, whatever, it's greater than this, but still this counter isn't switched on. So like I said, it only switches on the moment it's moving from a lower region, like from below the set point. Let's say if it's on -4 and then it goes to 5, that's when it switches on. So what I'm gonna do, I'm gonna switch on this decrementing. It's starting to decrement 39, but I want it to come quickly to this one. So I'm just gonna put a 0 there, so that it goes quickly to -1, 2, -3, -5. There we are. Nothing happened. Okay, nothing happened on our bit, which is M1. Nothing happened on M1. But when you switch this one off now, when it's now going into the accumulative range, it's going up now. This is going up. Remember, it's a number line from positive to negative. It's going up towards the negative. The moment it reaches a 5, it goes on. But the good thing about this one, when it reaches whatever it does, let's say it reaches that -5, it's gonna keep counting. What I'm trying to say is like you have a rotating wheel, or you've got bottles that are going inside something. And then when these bottles are going in, this thing, even when it reaches the count value that you mentioned, is gonna still count more bottles, like whatever that is passed in, is different from an ordinary counter. I'm gonna compare it. Maybe you're not getting what I'm trying to say. So it's already passed. So if I switch this bit on again, it's gonna decrement to our set point. While this is doing that, I'm just gonna add another counter here so that you guys can actually see the difference between this counter and an ordinary counter. Okay, let's wait for it. Because this bit C200 is supposed to go off now when it goes below -5. There we go. Okay, so you see how this thing works. So what I'm gonna do now, I'm gonna add a normal counter. I'm gonna call it C0, and then I'm gonna call this D1. Okay, so I download this. I'm in online editing now. If I download this, and then okay, and then I need to change this to my target value is 10 here, and then I reset this one. Okay, so let me stop so that they both start at the same time. So that they both start at the same time. Okay, this is 0, and then I'm gonna change your value there to 10, and then I'm gonna change this one to 10 as well, right? And then I'm gonna run now. Okay, so these counters, they are reading from the same register. This one is an ordinary counter. It doesn't have an up-down function. So when it gets to 10, this one stops. But this one keeps going now. You see? It keeps going. So if there are like offsets or things that are coming in, you can still get track of it. Or it's a rotating wheel with an encoder. Let's say your motor is turning, and then there's a proxy that is picking up the pulses. You can see how much it has overlapped from your set point. So your set point is 10. It tells you that I've passed with like 20 more. Like now it's passed with 23 more. It has passed with, let's say, when it gets to 40, if it's 30 now. So 10 plus 30 get to 40. Then you can see how much you have passed. So if you decrement here, it's not going to affect anything, which means if you decrement, it means that motor or that wheel is rotating back again so that you can come back to your 0 point. I don't know if you get what I'm trying to say here. It's like, let me just, I don't want this video to be too long now. I don't want it to be too long. So what I'm trying to say is you have a rotating wheel like this, and then this wheel has got some spikes like this. So, and then you have got like a proxy sensor here that is checking, that is counting these spikes. So if you have an up-down counter that is connected to this input X0 to your PLC, it's counting 1, 2, 3, 4, 5. Maybe when it gets to 10, it must stop. But then now it gets to 10, and then something happened. And then it keeps going on. It keeps turning. But this counter now, the good thing about it's going to keep track of how much it has drifted from 10 to 10 of these pulses, right? Then it has drifted with, let's say, 20. Then what you do, you go on your drive and then you press reset, and this wheel goes back again. So when it goes back, it starts to subtract 1, 2, 3, subtracting until it moves from 20 back to a 10. Then you are back to the original position. So it's just the explanation of how like a countdown and up works in a Delta PLC. It's not like I'm doing an example on how to use it. No, I'm just showing you how it works. That's how it works. When it reaches whatever it reaches, let's say it's I want it to go back to 10. I'm just gonna move this value quickly to, let's say, -5, so that it gets to 10 very quickly. I just want to show you how this reset works. 2, 3, 4. So I don't really use this when I'm programming. This is it's actually a waste counter to use. I don't want to lie. You can use a reset here. If you click this pause and then you rise it, it's still gonna reset your counter. But me, I don't use this counter. I only use a general one, a count up. Okay, I don't really use a count down and up in a Delta PLC. I use increment and decrement. Now I'm gonna do an example where you can increment and decrement. That is a very flexible instruction and is good and is very effective and efficient. So if this was really helpful to you, and thanks to the guy who actually requested for this, it's really gonna help other guys on how to use an up-down counter. Maybe someone is gonna find a purpose for it or an application for it. But me, I don't really use this. I prefer using a normal counter and then a decrementing and incrementing. I will do an example about that. I hope I answered your question. Thank you.